So now we'll be talking about how vectors could be equal. So then it's about equality and being parallel. So then these are the two things that we'll be focusing on as for now. So let's say I have a couple of vectors here. They're already present to you. So we have OA, BC, DE, FG, and HI. So if I ask you, in your opinion, so think about it. Which two vectors are equal? Which two vectors are not equal? Which vectors are parallel? Okay, so for each question, you can stop the video and then think about, okay, so these vectors are equal, these vectors are not equal, and these vectors are parallel, and then why is it? So it's like, what is it, the reason behind, or how do you know so then you can say, oh, they're parallel? How do you know, or how can you convince anyone that they're parallel, they're equal, they're not equal? Okay, and let me explain to you here. So the idea of vectors of being equal, I mentioned it in the very first video. We can say two vectors are exactly equal is when they are exactly the same in magnitude and direction. So then in the sense of this, so then let's list down which two vectors are equal. Let me give another color so then we can see. So vector OA, we can see the direction is it's a 2, 3. So then we should find another vector that's also exactly 2, 3. It should be exactly 2, 3. So then let's see. There's 1, 2, 3. There's also 2, 3. This blue one, this is negative. Sorry, my bad. It's not 2, 3. Why is it always 2, 3? It's all should be 3, 2. 3, 2, 3, 2. 3, 2, and then the blue one, the DE is negative 3, negative 2, and then the black one, the HI, this is negative 6, negative 4. So if you see it from here, so which two vectors are equal? So you can see exactly they're the same. 1, 2, 3. Because they're exactly the same, then only you can tell, or you can conclude that there's three vectors. OA is equal to BC equals as well to FG. They're exactly equal. You can tell. So that no matter where the location is, you can tell. You can say that they're all equal. But then how about the remaining vectors? Parallel, equal, not equal? Because those three vectors are equal, and then definitely the rest of them are not equal. Okay. Even though, like, for example, the blue vector, this one, even though in terms of the magnitude, it's actually the same with the OA, BC, and FG, but in terms of the direction, see the arrow, it's not the same. So then we cannot say that they are equal vectors or they are the same vectors. In fact, but then we can touch on with the next term, which is parallel. So what do we know about parallel? I think in probably in Sec 1 or even primary, we should be exposed already with the idea of parallel. So any random two lines will be said as parallel if, just give you an example, if I have, like, let's say, like, I can draw a line here. I have this line and I have this line, for example. Are they parallel? We know it's not. So like this example is not parallel. But then, based on what idea that they're not parallel? Like, how do we know? We know that the idea of being parallel is that when the two lines are intersecting, so then they are not parallel. So then, in other words, if they are not intersecting, no matter how long you extend the line, they'll be parallel. Because they will not intersect each other. How about the direction? Does the direction matter? That's the thing that we have to check in the terms of vectors. So if we see, let me just give you an example. FG vector and DE vector, are they parallel or not? So then if you see the thing, they're having a different direction, but then if you see the number, they're actually just the opposite, like negative of it. So then that's also another term, opposite. So FG and DE are opposite. vectors because it's just the minus of it, and then they are parallel because this is the opposite actually. It means that they're actually kind of similar, almost the same, but they're just having a different direction. Will they meet? Will they intersect? Never. Okay, and then how about HI and with the others? If you see the type of the vectors, the vector HI, if you see the type, even though the direction is different with some of them, but then if you see the number, again, if you see the number, -6, -4, or just see the 6 and 4, how do you think this number is related with the rest of the number, the vector? Can you see the pattern? Yeah, that's actually just like a multiple. When you times by 2 or you times by -2, then you get this vector HI, isn't it? Right? So then in that sense, you can say it's a parallel. Okay? So then that should give us, let me erase all these things. Let me erase all these things so then I can make the formalization, like the formula. So then equal is rather easy because you can just see it. But then when it comes to parallel, we need a condition or a formula, let's say. So then two vectors, let's say vector A and vector B, or you can use the arrow thing, it's okay, are parallel when A can be made as a multiple to B. Okay, I'll just give an arrow so then you can see it means vectors. So whenever you can make it as a multiple, so then A equals 2B, A equals half B, A equals even negative half B, just like this thing. So then we can tell they're parallel. I'll give you more examples in the next video.